So this set point, I'm assuming it's adjustable by us, but the
Yes.
occupants have a
No.
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 The occupants can only adjust the temperature.
Temperature,
set like
right.
you normally would in a room.
Okay. Everybody good with that one? Meg room? Okay. Moving on, next big thing, we did that, we did the Meg room. The next big thing is the pharmacy, the famous pharmacy. Alrighty. Whoa, Jimmy's been busy. You're not sleeping at night. This is good. This is real good. Okay, let's figure this one out.
Yeah, please
This one only took you 5 minutes.
Alright. Let's figure this out now.
enjoy.
Alright.
Alright, the rest of the day.
Choke on this. Alright, so the entrance, the main thing is this is the entering into this is the main entrance into the pharmacy area. This is the path that you'd be taking, in here. So we have differential across this doorway here. And so what do we
That's the
have?
corridor door. Right there.
Right below the mouse is the value.
Okay, so this
So
is
those
the
your door
these are
sizes?
hold on a minute. These are TSI electronic sensors, no?
No, all three of these currently, all four actually, in
Sectors.
this case, are all sectors right at the moment. They just purchased, you see room 7223 just above where you are? Yep. The two devices in and out of that room,
Yeah.
those are gonna become TSI devices, just those two.
Okay, because they're
Yeah.
high.
Yeah, we're gonna be wiring those up next week.
All right.
Yeah, they just came in.
So these are Cetras here for now, and then
Yeah.
I thought we were going to change all these to TSIs. No,
No, that wasn't the case.
only these two are TSIs, and this is a Cetra.
Yes. And the other one up top is a Setra as well.
You know why? This is why that happened. Because the pharmacies, I think it's PST or UST, something like a PST, is 797. They tell you this anteroom is an anteroom to the main prep and actual making the drugs, or they do compounding in here. You ever heard that termination when they do that stuff, right? These two have to have a relationship to each other, and this is what the inspectors look for. They're not looking for this relationship here to here. They're looking from here to here. Okay? This is the relationship they're looking for. So that's why these two devices, because this area out here and this area in here, the two things that the estate, the pharmacy industry, pharmaceutical industry looks for pressure relationships to anything else. These two areas here just exit out of the area of the pharmacy that we want to look at. So the most critical things that we want to be maintaining is this and this. These are going to be changed up to TSI indicators. These are just Cetras above the door, as I'm being told, and the values from these Cetras are right here. Okay? We have to maintain certain pressure relationships between all these things, all these devices. Okay? This is pretty good, Jan.
Thanks.
So you got there, you got the Cetra there, you got that, you got the device coming across there. You got the basic diffuser in setups from your supply air coming through here. You have your exhaust box showing your two exhausts coming out of the space. You've got your supply box coming off this T-stat. I'm reading it. Supply, each one, right? These are scrubbers, guys. These are HEPA filtered scrubber units, okay? So we'll click on them. So these are fan powered boxes. All right?
They certify their own, just like they do.
That's right.
downstairs,
They certify their own HEPA filtration in that room. So these are all fan terminal boxes serving that space. We have radiant panels in there? Did you catch that?
Check rad panels. And
All right. See, you're jumping right on us. Oh, change that. So we'll have to get rid of that radiant panel. So, and fan trial terminal boxes serving the space.
Yeah.
And this is really make sure we really understand the area thing that's the
Right, they like
it's
one on there.
it's the pharmacy. It's considered a that's a compound. It's a prep, drug IV prep room. I think it's considered. IV prep room. Oops. So you have one here. You've got another box here. You got another box here. boxes, so you notice there's a lot of scrubbing going on there because they need to get so many air changes. So when you're doing calculation for air changes in space and pressurization, it's not really happening. It's happening through the fresh air makeup, right? System. I'm assuming it's this T-stat, but you don't click on that. That the make air. How do I know how much my makeup if? Do I calculate from the boxes or something? How do I?
So the flows are on the,
Oh, okay, good. I got it now. So
and the blue line tells you which ones are associated with which exhaust
exhaust
box.
box.
And so then on the left side you can see, or the right, given.
all flow values in CFM.
Yeah, just so that I don't have to type CFM.
So how do I know if I want to know how much supply is coming in this space right here? Do I look at the 7002 room?
Yeah, so 002 and the one above it,
Oh
which
no,
is
here it is.
001, you see the blue line coming off of it, and it's going to an exhaust box which has also a label.
This?
Alright, and then you associate with that with on the left side there's, on the right side.
Right down.
So I look at the room. It's 7233.1. So where's
There's
my,
there's
You-
2 exhaust boxes associated with 5 supply boxes.
yeah, this
Okay.
one.
Another
And that
pink
one.
elephant.
Right. So you have the 2 on the top
Yeah.
associated with the 1 on top. So you take those 2 and the 1, right? And you get that. Where did I put that? That's
Right here?
over on the top right. So 1 and 2 are with 37, right? So you can I can total that up if you wanted to, and give you that those are the totals, supply and exhaust for that area.
You did that already on the top
I
left.
think you did right here.
Top
This,
left
that's what I
of the
said.
room.
This here must be that.
7233.1.
Total supply, total exhaust.
That's that one.
That's what I'm assuming.
For
That 'cause
that
I saw that
area.
room number.
Just for
Two,
that-
three,
yeah,
two
it's
dot
just
one?
that room,
Right.
Just that area.
That
All the
can't
values
that
combined.
that can't be right.
That is.
That can't be right because that's a wicked positive room to anything around it.
It should be.
That's the most positive space to anything around this area. And according to this, it's negative.
Are all the air handlers ramped up to regular static set points now though, or?
Yeah.
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 Yeah?
So I don't know how that calculation came out, Jimmy, to be honest with you.
They're gonna have ball indicators on those 2 doors, right? You're saying? That door and that door?
This door here has a ball indicator. This door here has a ball. Don't they have ball indicators, Steve?
Yeah.
I'm sorry,
They do,
Steve.
but I think the idea was to
Yeah.
scrap them, wasn't it?
To
When they-
remove
when
the
they
ball
put the
indicators.
TSIs in?
So what exactly are those icons over the doors representing?
Cetras, differential flow.
Okay.
See the balls.
So,
You know the little
Pressure
balls,
transfer.
the
Little
pressure
balls on
balls
the
that
road.
run in and out?
Yeah, but we're not putting the balls because we're not required to maintain this and this. We want to know what they are for our troubleshooting purposes for Cetras. We are required by compliance to have a device here and here, and those will be TSI devices with actually digital readout. You'll see what the differential pressure is, not just a ball. You'll see a
They're
reading.
gonna have
we have one of
two-
And you
those
have to-
that meant,
And those all have to be 0.05,
Nuke medicine, second floor.
a high differential.
Alright.
Okay?
Outside that fume room, the radiation room on nuke medicine.
Is that right?
you see 'em.
I said it right. Okay.
There's, we could not come up with a way to monitor those 2 doors. Those are the swinging stainless doors with
Right.
the rubber grommets, so.
Right.
Yeah, or gaskets, so, and they're not sealed tight either, so.
Right.
Yeah, so we won't be able to disable those pressure alarms, those are gonna always be active.
No, we'll have to have a delay on them.
Yes.
A delay,
Yeah,
adjustable
delay,
delay.
yeah.
Adjustable delay for us.
Just wanna let you know, because, and the wires are still sitting there waiting for those door switches, we just couldn't get them to go, we couldn't figure out a way to do it,
Right.
physically possible.
Yeah, I
So-
don't think there'll be so much an issue, because that room, they're always,
Oh,
those doors are always closed, and they're
Yeah.
always.
up a pharmacy, they're wicked.
Yeah, those doors will always be closed, it's not like the isolation rooms where people
Mm.
play with,
I'm surprised they don't have airlocks on those doors.
This is the airlock right here. This room. This is the anteroom. It's an airlock.
No,
To go in and out of this room,
I'm
that's how you come in
surprised
and
they
out.
don't have, where, up on 7, I believe they, on this, one of them, you can't go through that second door until that first door is closed.
Oh, I see what you're saying. More like a close this door before that closed?
Yes, like in,
Yeah.
like an arch area.
But this is this is technically the,
Where was
Seven.
Like,
When you're going through,
Yeah,
when
there
you're going
is-
through
you
the
go
film
over
hood
the-
rooms.
you open the one door, you go into the little vestibule, then you go into the IV prep room
Yeah.
after that. I don't know
Yeah,
if they're
it's not-
interlocked.
they're not
I don't think
interlocked.
interlocked either.
Oh, yeah, they're not
They
interlocked.
used to be.
Yeah, no, they're not interlocked. They have an anteroom, but it's not
Yeah.
interlocked that I'm
So-
aware of.
This is that. It's basically this what you're looking at. That same kind of
Yeah, same
process.
stuff as that.
So I still not sure how these numbers. This doesn't make sense.
There's no windows up there either.
It has
are
to be for us to be positively pressurized. That has to be pumped up way more than that. So we'll have to figure that
There are
out.
openings where equipment goes into between
Right here.
those, yeah. But I believe they get sealed up. I don't know
They
if
do.
they do or not. but I believe
Completely
they do,
sealed
yeah.
up.
Yeah, that's what I'm saying, is I see all that.
They those are just pass throughs once the equipment
Yeah.
gets installed.
Yeah.
So, all right. Well, we'll have to do our due diligence there and find out what's going on here from the balance reports versus this information.
Yeah, I just don't
'cause-
think the balance, because if the balance,
The balance
the
is-
balance, it checks all
The
that.
balancing does not make sense for that room. They show a negative 650 at maximum, and they show a neutral room at minimum. And I was on the
It's
phone with
showing
Eric, I'm
pretty
supposed to
close
go
to
over with
neutral
him
right
on
now.
Monday, because the balance
Alright,
was
alright.
lost too. So I said, all right, I'm gonna jump in and
Alright.
see if we can figure this out.
I mean, put it this way. The only way Charlie Bean's going to get a commission report out of this is every one of these systems is completely online because they can't move in. The
Right.
pharmacy
Yeah.
cannot move into this. It's going to be a big thing. If they don't get their commissioning record, they can't move in and use the space. So that's going to be a huge thing if this doesn't work the way it's
Yeah.
supposed
Well,
to
I mean,
work.
the balance is, supposed to make it work, but he's lost too, so I don't.
Well,
Yeah.
I'll be honest, well, if you look at the pressures are good though.
I don't think so.
Get .1, you
No,
get .1.
that's not good enough, Jimmy.
No, they.
Well, I'm
The
saying
regs-
the pressures are good.
No,
No,
the
they
regs
need
on
more
seven,
than that,
the regs on that's not accurate.
That's all
The
changed.
regs, it's all changed. The regs on that, these are .0, I want to say 03, .03 across these doorways.
That's
Min-
a
min-
point.
minimum .03, right?
Minimum .03.
That's .1.
Oh, I'm sorry.
That's what I'm saying, that's .1 and that's .1, so that's way over, so from a pressures perspective.
Oh,
looks
maybe
like
you're right,
everything's
maybe you're right on
okay.
that.
Was it .02 they're looking for?
I think it might have been .0.
I was thinking it was .2.
It wasn't .01.
No, it's .0 is .0.
.01 is what we normally
Usually
do.
It's .0, it's either .02 or .03.
Isn't it .01 we usually do for
Yeah,
right,
.0
all
is
our
what we
stuff?
used to do.
And
theirs
theirs is .02
This
now.
is point, yeah, it's up
But
there.
I'm saying it says .1 and .1, so from looking at it from that perspective.
pretty good.
It looks like the pressures are right, regardless with the exhaust sound and all that.
Exactly.
That's what I'm saying, so it's.
But it doesn't make sense, so how could you
Well,
have
that's
that?
what I'm saying, it doesn't
I
make
think
sense
it's
with
out
the
of
pressures.
whack anyway, like I
Yeah.
said, because they didn't know what to set it at.
Okay,
you know?
all right. So we're not gonna, we'll just look at the graphic and look at the information and we'll make sure from that standpoint if
Yeah.
we gotta get at the
On
end.
our end, what's gonna happen if one of these fan power boxes drop out? Are we gonna have it enough capacity to keep that room where they are? Are they gonna have, what's gonna happen with
Hey,
FAS? Are they gonna evacuate other?
This ain't the meeting for failures.
Yeah,
We're
that's-
not
that's
talking about
yeah,
failures.
Yeah, that's a whole.
This,
we'll
we'll talk about things that break later, but right now,
Yeah, get
I
rid
just
of
got, I gotta get through how this all works before failures.
Off the top of my head, I would say you could probably lose one box and we'll have enough to.
These are all scrubbers.
A lot of rat race
They,
going
these
on.
boxes don't maintain pressure in the room. These boxes scrub the air.
Okay.
They're just terminals to scrub the air. So we got that there. We have this thing here. Now this is just the holding room here, and so you put another fan powered box here.
Could be a VAV.
That's not a fan power box.
It's not. All right, Jamie. Well,
I separated supplies, and you can see the thermostat.
okay,
So the thermostat is associated with, I just put the box where the box was.
okay.
The thermostat where the thermostat was. And then the colored thermostat for a fan powered terminal is over there. And then it's associated with
So
those
it's-
supply boxes.
Are you telling me this supply box here with this dotted line is associated with this exhaust box?
Correct.
That grill is actually on the other side of the wall.
It's
Yeah.
not in the pharmacy.
Yeah.
Then you gotta, because that's what really.
Physical
I'm saying
location
that's
of the box,
impossible.
yeah,
You
we're
you
gonna
can't
slide
cross
that
over.
Grill over a little bit, yeah.
Slide that over and put it over here. Either that or take the whole thing out of here and just move the whole thing over. Because if
I'm not
this,
sure where the box is located,
You know what I mean?
gotta go find it, you know.
get it off.
Can I
there.
ask you a quick question, 'cause I'm not, the pharmacy, right below that, right
One
where
of
his
the
arrow is.
mechanicals I had.
Sure,
I
shows those,
had
like,
the
column
diffuser,
things?
I know.
They're the doors,
But
that
it's-
open space.
actual is a little
Right where
different.
that exhaust grill is we were just talking about, I think there's a
Well,
door
we'll end
there.
up doing,
So
to be
there's
honest
like
with
some
you,
kind of sliding
before you
doors,
go
those
making
open
any of
slots
the
on
major
it.
Putting
infrastructure
equipment
changes,
in between.
I'll have
maybe
Robert
it's
go
not a
up there
door.
in
Or
one
it's
shot.
just
Well,
open
seal
to
So you're gonna
area.
do it in one shot.
Equipment over there, and
Move
then
this
the
over here, put
slot
the
there.
diffuser there, okay,
I
how it's
haven't
actually
been
laid
up
out,
there in a bit.
all
I
right?
was asking the same
Mhm.
question when I saw all that stuff with the equipment. They're putting all the equipment
Yeah.
inside of all
Oh,
of
okay, well,
You
those
say
open,
they
those
seal
like.
This-
spaces
just-
on the show. Okay, I just meant those open to the space.
Jimmy, this here
Yeah.
all has pass-through equipment all sealed up. This is a
Okay.
box.
So that, yeah, that's what I'm saying, so that is gonna be
This is all sealed
up.
up,
Okay, so
yes.
I'm trying to
Maybe we should
ask
show a
the-
barrier there.
You should.
somehow.
That's what I'm
What I'm gonna end up doing for this one, just so we're not gonna go crazy here, is I'm gonna probably have either probably yourself, Jim, take the graphic disc up there, go up there and just read like we did the CPD, and just show this exhaust diffuser's here,
Yeah,
this
when
here.
everything's all
Fix
said
it all
and
how it
done,
is
when everything's all
actually.
said and done, yeah.
Then we'll give it back to Jamie, and then Jamie can do
Yeah,
it once
we
for
can
all.
get the as-bills and get this,
All right.
hopefully if it's
It-
correct, yeah.
Yeah.
I just wanna go up there and look.
Yeah.
Just go up and physically look.
I hear you.
You know, that's the quickest way to do it. And then as far as that, once we do that, we'll see how this flows, Jamie. This is great. You've got everything. It's just now how we want to just
Mm-hmm.
move it around.
Yep.
Shuffle the deck.
As long as the data is there, I'm happy. We can reformat it however
Exactly.
you want.
Alrighty. Flow control, they did
A
that.
lot
temp-
going
Okay.
on there.
There is a lot. Okay, so I'm not gonna bite onto this too much as we know that there's a high sensitive area. We're gonna get this thing more more set up to be actual exactly how this stuff is. And I think for our purposes, we're gonna get you the information to say what it's supposed to be. So if you look at a graphic and it's supposed to be 0.0 something regs, you'll know that there's a problem. There might be a problem there because we don't have that information. We're kind of guessing. You know what I mean? And plus, I don't know where I know all this stuff is set up in alarming. I don't have all that alarming. You know what I mean? I need all that alarming. I want adjustable for us. You know, all that alarming for all these devices. You know what I mean? Meaning, this thing's supposed to be set up for alarming. If it goes below X, we have to have an alarm to tell us there's something, pressure in the room went bad. I know you must have it.
I do. I do.
We just got to get it
I
up there.
mean, we have all of the obviously the ones that are gonna go for the
The air radiation.
AV reg things.
Mhm.
Yeah.
Yeah.
Pharmacy belongs to not the air regulation
Right.
business. It belongs to USP 797.
Okay.
It's totally different whole thing.
Your two TSI devices will look different. Whether we're able to set that alarm or it's actually physically set on the device will depend on what we get for that device when it gets installed.
If that's the case, then it's just free text on there that what the alarm parameter is, so we can reference it. If it's
I don't
something
know
we can
yet,
do,
I'm just speculating. We'll find out when it gets in
Okay.
next week, see how it works, you know?
all right. It's got a little bit of work to do for this one, but all in all, great effort in the beginning. Alrighty, so we got that. Anything else on the 7th floor? Anybody want to talk about
Those are those two special rooms. That,
these
Or
two?
just defensive radiation. with
The
it.
fin
Yeah.
tubey things that we talked about?
mm-hmm.
Alrighty.
Not fin tube.
And then we have the pump, the hot water again.
Yep.
That goes to the hot water for the plumbing. Domestic water, cold water.
Now, wait a minute, we don't have our, we don't show it's probably on the other screen.
It's right here. The UPS is at
Yeah.
flow screen now.
Okay, there it is, yeah. They had to shift the low voltage room over to the other side of the building on this floor, and then it goes back again to 8,
Oh.
on the
Mhm.
8th floor. They had just, because of the pharmacy.
It's right off the staircase right across from it, yeah.
Right here. Good.
That must be fun.
That's UPS.
Yeah, the
Yeah,
rising
you
pipe.
have to
had
go
go
the
like
rising
this.
all the way across.
Yeah, and back again, yeah.
So it's really good. I mean, for this floor here, we got like no air on this floor whatsoever.
They may have just shut the unit down, who knows?
Yeah.
That's unit number 3.
But I like it so far. It's looking good. Moving up. 8th floor. Same thing. Actually, we didn't have any ISO, nothing there, right? No. Then we move up to 8,
This is a two-page
and we have
report.
one of these rooms. Now, I was told that this room also is the same thing that happened. It's not an isolation room because of the program space, and it's a positive pressure room.
Okay.
It's not an isolation room. I was told 6 and 8. I think which one email?
It is
did I have?
HEPA filtered though.
It's set up as a whole thing like it is, but it's a positive pressure room. I don't think he allowed negativity within the program space. DPH said no, you can't have a negative in a cranial transplant blah blah room. You're on this floor. So they in the AIA guidelines, you can't have that. Oh, it's okay. This was way back. Okay, it's a positive pressure environment room with an anti room. You know what I mean?
Yeah.
So I think I sent that to you guys, but I'll send. I'll do it again. But
When they finally figure it out, we can.
Yeah.
represent
It is figured out.
Oh, okay.
I'll send you that document. Eric sent the whole thing and why it all happened and what it needs to be and all this other stuff.
Pharmacy too, but-
You know. But that's considered, I believe, too, on the 8th floor, a protective environment room, not an ice, the whole bit. It's a different room. It's HEPA filtered. So maybe like how we did on the 6th North, we have a HEPA filtered room. Because then we have a color coded for those, like in main building, we have HEPA filtered rooms, and then we have ISO rooms. So maybe it's in that color classification.
Okay.
Can you write 6 for a second?
6?
Yeah, just for a second.
Yes.
Okay, I know, I heard it. All set.
Okay. Any you guys want to go anything over here? This is behind for the thing we talked about.
The low voltage room is over to the left again, back on the triangular room on this floor.
Which is on the
Yeah.
UPS backups, which is going to be over here, somewhere right here. Hey!
Oh, yeah.
That's what the refrigerator screen's going to look like.
Yeah, baby.
Now,
Refrigerator bombs.
Now, does that floor also have the exhaust?
It's got-
Supply boxes in the
Done for the
corner?
night.
It looked like I saw the keys.
if you looked in this one here, see CRN equipment?
One over there. And
Yeah.
Any
Yeah.
floor that has CRN equipment will have a CRN hyperlink to it in the screen. It's basically the same screen as the Flow ones, but Jamie added all the refrigerations on top of it, but you have a hyperlink by itself to it.
Thanks, Jamie.
So there's
So-
no refrigerators on anything below 8, or?
No, they're
It's
just not done.
shown-
They're just
right
not done.
now.
There is, but they're not done. So this is what you'll see for those. Every single one will have that. They're not hooked up yet, but they'll be blinking when an alarm, as you can see. And every single one of them will be click on and tell you a little bit about it. All right. And I believe I've
You
hit
want me
that
to remove that or make it historian button?
historian button. That'll take you to historian to get the drop down menu, which Colin hasn't done yet because I looked at it. He still has the FRZ0-84s and all this other stuff. Means nothing to me. He doesn't have the CRNs in it, but he's working on it. So you click on that, it brings you right to the historian drop down reporting system where you just look at that. You drop down, pick that CRN just like you do in ICE N6, and then you can form out your graph and all the readings on it, whatever you want, if you want to troubleshoot. Make sense? As that thing gets unfolded beforehand, I'll step everybody through it. A lot to this stuff, huh? Man, I didn't think it was going to be this. There's a lot to this, man. Jamie, you've been a busy boy.
Busy boy.
Okay. Does anybody really have any talk about that, the CRNs for all the buildings? No ICE N6 in
What
this
kind
building.
of refrigerators are going in there?
All
by the
us.
way? Just
Flawless.
fallets? Oh, fallets?
All self-closing door Summit
Oh,
units.
the Summits, okay.
It's the self-closing door hinges, so you open they'll self-close.
No more calling, telling them to close the door.
But if they put a big cake in there and you can't close the door, it's going to be propped open. It is coming alarming through FAS,
Call.
CRNs, and all that stuff. And it's no more Zen6, it's on LRs. And if you want to see any reporting or all that stuff, it'll be all set. You click on that link right from the screen, our screen. It'll bring you the report, and you can say, hey, well, what's it been doing for the last hour? You can hit your things in, boom, run a report. It'll show you the graphs, tell you all about it. All right? So we're trying to obviously divorce ourselves from Zen6 and bring it over to our stuff on our screens.
And
One-stop
And
shopping.
hopefully they got enough outlets in there so that everyone's not plugging their cell phones in.
Yeah, that's.
Well, we looked at all that kind of stuff, and we made sure that, we had dedicated stuff to it. Unit goes in. These all have they only have a Cat 5 cable, right? Is that right? Cat 5 cable?
Yes,
Or like a
correct.
Cat 5 cable that plugs into a box in the fridge, a box in the jack in the wall. The difference is now that the CRN in the back is a plate. It's like a phone to computer jack. It plugs in with that CRN number. They unplug, they move that fridge at all, we're going to know about it.
Oh, yeah.
It's going to come an alarm. You go out
But
and
you can
it's
plug
the
in
only plug
any
you
other
get.
fridge. Once they connect, it just sounds the same.
If they pick up a fridge with a different CRR somewhere and carry it around, they're probably not going to be smart enough to plug that back into the wall to tell you that's our automation alarming. You follow me? They're not going to do that. As soon as they unplug it, they're going to try to do something. So automatically going to let us know. We go up there, go, what the hell are you doing? You can't. This is all alarmed. See, you got the cables here. You didn't plug it in. You know what I mean? That all has to be live and active for us to get alarming. They disconnect
You
it,
can put
we're gonna
any,
know.
any refrigerator in there and it's gonna get the signal.
It's gonna get the sills,
Right.
it's gonna come
So,
up as
let's say if
CRR,
you
whatever
have a
the,
refrigerator, we
whatever
don't
the
have
jack is in the wall.
Exactly.
Right. I mean, a Sensix, when we change our
Exactly, it's a
refrigerator, we
pain in
have,
the, I know. It stinks. That's why we did this. Isexis is not in this building.
Yeah, we're monitoring the jack, we're not monitoring.
Exactly.
Exactly,
Yeah, whatever's
Better
in
f-
that
it's
jack
better
is
for
that
us.
CRR.
We can control it more. As soon as they touch anything, we'll know about it. And guess what? It's not going to be like that as N6 trying to figure out where devices went, what went where. You know, this box went with that one. It's none of that. It's the CRR jack in that wall is that alarm. You ain't moving it.
And each one's
can't
got a
take
little
it.
sign above it, so they don't plug their phone or their
Yeah,
Yeah.
computer into it.
see how many person tries to play
Yeah.
a laptop,
Right,
oh,
yeah.
computer, data
Yeah,
jack,
right.
laptop.
It clearly says there's a yellow,
Yeah.
you know, FAS alarming, refrigerator alarming thing, you know. So, moving on to, we'll go up a floor unless anybody wants to stay on 8. It's pretty self things. All the question marks at all the patient care floors, just like in main building, goes to our folders and all that kind of good stuff. Up to 9, it's pretty much a duplication of 8.
They're pretty much the same, yeah.
These stacked isolation rooms that are here. This is an isolation room on 9. And that goes to the exhaust fan system that's on the roof. That's isolation. We'll get to the penthouse on that. And then you have the exhaust fan, I think it was 12 and 13?
12,
That went
13,
down.
1 and 2.
And 1 and 2 is on the roof. 12 and 13 go down for isolation.
So they get those little exhaust fans all over the place, yeah?
These here.
Yeah, they're all over the place.
These
Like
ease,
every floor they get
But
them.
but
The
like I
upper
said before,
floors.
Jamie will put a little dotted line to tell you what box it's associated with. So you know it's one exhaust box and it's taking the sum of those and tracking that box, okay? It'll help us to identify how it's all working. And every time you click on it, it'll open up the dialog box showing you the supply box and the exhaust box. It'll tell you all about it, what it's doing. This one has 3. It's tracking 3. Okay?
So for most, I think you talk, for the most part, those exhaust fans are on the hall somewhere.
They're not fans,
They're
they're
exhaust
No, they're VAV
Right,
boxes.
AV
Yeah.
boxes.
Yeah.
Oh,
Exhaust
I'm
boxes.
really losing
Working
it.
It's
with
just showing the
multiple
relationship where there's multiple supply serving, you know, that are married up to the same.
They're
exhaust
actually
box.
what you consider, they're return boxes.
I'm sorry, return.
They're
box.
return
Throw
boxes.
another curve, Jamie, and put an R in there instead of an E.
Oh, exhaust box. Okay.
It's exhaust, but it's really a return box. It's return boxes, not exhaust fans or exhaust boxes. Those are returns. Okay? And they're tracking supply. We don't exhaust. Next, you know, UPSs, flow measuring, so everything's in there. You know, I don't think the refrigerator, you know, all that kind of stuff. Can I go up the next floor, or you
Yeah,
guys?
sure.
Okay. 10, same.
Yep.
No different, same stuff, same things, everything goes on. No specialty stuff here, it's all the same. All right, we got up to the penthouse. We have, these are the whole chill water plant and all that kind of business. Let's click on, these are the condensing water pumps for the cooling towers and all that. But, and these are the I'm gonna open them up, but these are the FEPs.
Each one
Panels.
has
Yeah.
UPS.
Those are the
UPSs
Yeah.
on the FEPs here. Here you see all the little symbols. Symbols. You see them all over, okay? These are the chillers. These are all those chill water circulator pumps. May temps are here. Our chiller plants are here. Our air handler, exhaust fan that's up on top, exhaust fans up in the ceilings. Exhaust fans that are in the ceilings. Filtrane units that are up there. Filtrane pumps for the cold water pumping. This is dedicated to this system here for HU3 that serves the pharmacy area by itself. I'm gonna click down real quick to make sure area serves the pharmacy shows that shaded. Did you do that?
Yeah,
you
AG3
did
is the whole
Seventh floor. Okay, you did that. Okay, good.
That's the only
Um,
one.
Heat exchangers here. This is building hot water heat. These are the pumps. And these exhaust fans. Okay.
Those are the isolation rooms, I believe, right there. Do you think it's crucial
1 and
that
2.
those ones are set up a little different to maybe throw in something there saying for that manual reset that
Yeah, you were up there when we did
I
it.
was when you were commissioning them. That's why I said that. Yeah, because they're set up differently than everything else.
So 1 and 2 are right here. You click on that, and that's your 1 and 2 fan. Same as set as the 12 and 13 on the 4th floor. You set them up the exact same way, same resets, same configurations, same. Okay. These are isolation room,
What those fine
technically 6. Is the 6th floor room ductwork come down to here for the exhaust in that area?
I forget how far down it reaches. Oh yeah, 6 through 10, it shows it right there, yeah.
So that does go to that particular room then, it must, if that was on
Oh,
the original
yeah.
contract drawings.
Yep. Good point.
So we talked about these exhaust fans there, we talked about that, let's go right to the chiller plant, right? Okay, chiller. These are our main two chillers here, chiller 1 and chiller 2. Chiller 2 is actually running right now. Chiller 1 is in standby. And where was the first screen that had the things in it divided?
The whole system is at the main screen. So these, if you
the
want to see just the
individuals?
individuals, that's there.
Okay, I want to go back to see.
And if you want to see the condenser water
Yeah.
pumps, that was there.
That's what I want to see here. So this gives you the whole basic building layout of the chill water plant. This box here, when I hover up here, see how it opens up like a box up here? This is the cooling tower setup. So I clicked on that. What it does is basically if you give you CT1, CT2 cooling towers, it tells you which one's operating, which one's off, and which ones are actually commanded on. And if we wanted to start off and say the flow will come out of the towers first, they come out of the basins of each tower, come out here. This valve is this valve here, so it's commanded open. This valve's commanded open, so these valves are open. Water flows down here. This bypass valve here is closed right now, and there is a program to say that if it's so cold out that you can return a rat race water back. I believe it goes back to it just bypasses the towers here and goes back up through and does this.
Normally closed.
Yeah,
doesn't it?
tries to maintain like 77-degree condenser water.
Oh,
Water
well, it
continues
says
to
it's
chill
normally
here.
open, no, that's actually normally closed, right, the bypass? No?
I'd have to see what I have it. I don't know if it's normally open or normally closed, but normally it's going to try to maintain 75 degrees. Temperature continues to
Is
rise
this-
in the center of the tower.
Is this here for that valve? This information?
Yeah, 75 degrees. It's
Yeah.
going to try to maintain 75-degree condenser water.
Yeah.
If the water continues to rise, it's going to obviously divert the water up to the tower.
Mm-hmm.
Tower's going to come on. It's going to try to maintain that max set point of 77.
Yeah.
So the tower fans are going to stage on,
Mm-hmm.
and then to maintain the 77. And then if it's going to obviously the speed of that fan is going to go up and down off the temperature to control for that set point. If the water continues to rise, there's another safety in there as far as for like a lag. It will actually bring on another tower fan if it can't keep the load, can't bring the temperature down in the water. I don't know if that number is reflected on the screen there, but there's another, it's like an offset set point, like the 3 degree. So if it goes like to 80 degrees,
Yeah.
it will bring the second one on, the second tower on, and the second tower will start if the first one fails for some reason,
Okay.
being the pumps, the VFD, not the, there's nothing in the tower per se, but the VFD fails, it will kick on the other one. back.
So I'm gonna head down here and say this is tempered, cooled down, returning water coming through here. It picks up a sensor, and that's what it's trying to maintain here.
And for the sake of argument, not to interrupt you, but
Mhm.
the cooling towers originally with one tower enabled, one tower went with one pump, the other pump went with the other one. The isolation valves that were associated with the tower, that would open if that one was enabled to run, the other one would remain closed. But now they changed that as far as for the water flow reasons. If one of them, whenever the tower is initiated, or enabled, I should say, both isolation valves are open. So you'll see both of them open at all times.
Which is this and this.
No, the ones above it.
Yes.
Oh,
This
those
here.
that's a normally closed position when they fail, okay.
These are normally open, right? So these are open when it's commanded on. So water can flow through. So it comes down here, goes into either this pump or this pump. Okay? Either pump. This one here in the middle chill, the pumps that are up there, the condenser water pumps, the one in the middle is a manual, operating manual valves before starting. This is not an automated pump. This is a backup with manual operation. These are automatically. One pumps lead, one peg legs, and failures, and they switch. Comes out of here. If for some reason you needed to use pump number 3, you have to manually open the valves and force that pump on. Okay? It's a valve operation. Automation wise, you can command it on. Valving, you gotta valve it off. It's not automated. So then discharge out of the pumps, come down, and it feeds chiller 2 condensing water or chiller 1 condensing water. Alright? And make sure I get the information correct here. This is the command status. Closed. This pump is disabled. How can I get this thing closed up? How do I drop that line down?
Right click. Properties. Auto hide. Top. Up. There you go.
Right ahead?
Yep. And okay.
So then I go like this, it pops up. Good. So that's enabled. So this comes down, comes out, discharge it, sensor and all that stuff. What is this here? Command closed, command status closed. Oh, this one's for this. There it is. I just lost this. This commanding is for that valve. So because this is enabled, that's commanding this valve to be open to flow water.
The chiller controls the valve.
The command. All right. And then it discharges out of it. This one's saying it's disabled, so this command valve right here is closed. So all the water's coming down through, coming up here, heading down this way, not going through the bypass, because it's zeroed out, so it's not going anywhere. So it's going up to the tower, top, feeding in both towers. This one here is operating in at 15 amps the fans. It's commanded on. It's not over it. It's a speed. So it's asking for a 29% speed to maintain this temperature, I'm assuming?
Yep.
These temperatures. This one here is just splashing over, and it's just cascading. This is not operating right now, but it's cascading through for flow, coming to here, and it's mixing, and it's coming to here, and it's getting in at that value. Is that right?
Yep.
Okay. Everybody get that? I just stepped through the whole thing.
There's no fan operation on cooling tower 2. It's just cascading down and just going through the fill, and that's it. That's why you get a lower, you're getting a higher basin
Yes,
temperature.
there's no fan running on that one, it's just the water's just cascading down the tower. And as that condenser water gets above that max set point,
Right here.
Mhm.
It'll stage this on.
if it goes a couple degrees above
Above
that
it.
max set point, it's going to,
Yeah.
it's gonna start to stage.
Free cooling.
Is it-
That's just gonna rely on the load. If there's a heavy load, that's when
That's right.
CT2 is gonna kick in.
That's right.
They do run.
Oh, trust
We've
me,
seen
yeah,
them run
that
100%
Yeah,
both
both
fans.
of
I
them.
Yeah.
bet, yeah, I bet it will.
In the 90-degree days. Okay.
And that's just the condenser water loop on that box. Yeah.
What is this little doohickey daddy thing right here? Makeup feed?
That balances both.
Is that makeup feed or
That'd be
something?
feed water.
Let's
make up water.
Let's make up water.
That's what this is, Jamie?
Yeah, which you guys don't control, it's got its own controls, right?
It is. Yeah, Molly has its own panel up there.
I don't know if you put just a small little text here, makeup feed, that little arrow thing or whatever that is.
Yeah.
Okay? I like it.
Okay,
It's got everything we need.
can we go to the chill water?
Yeah, absolutely. We're going there next. Next is that's the cooling tower box. Next one we drop down here to the chillers. Now,
No.
oh, I'm sorry. Which one? You
Can
don't
we
want to go
back
here?
to the cooling tower again?
Okay.
Is there any way of differentiating the color of the lines? Because when you're on the screen, and that's chill water.
I think they
The blue lines are the blue lines that.
These are different lines here. Condensing water is different than
Yeah,
this.
different. One
That's
side is
condenser
systems,
water,
Yeah.
one's
You can see
lighter,
those
the other
lines.
is-
I see.
Yeah,
and these blue lines are the chill water for the plant. So they are.
That's a main screen.
Yeah.
cause that's how they're wrapped up there, right? To differentiate
blue.
the.
Light blue, dark blue.
Yeah.
So I'll go to the chill water one phase. These are the two chillers. Lead chiller number 2 what is it, lag call to run is off, that's off. Lead chiller number 2.
If you have extreme conditions, you may have to run 2 chillers, so.
Yeah, so that lag call to run, that's just gonna give you an indication in the program, when I wrote the program for them, that, you know, something is calling the lag one to run, whether or not one can't maintain temperature or, because primarily the chiller's gonna run. If one fails, the other one will end up starting based on the timing and the temperatures. So normally you'll be more concerned that if the lead chiller is running and the temperature is like 5 degrees above set point, it's gonna call on the lag chiller. And if the lead chiller is running and the demand on that chiller is above 95% for like 20 minutes, it's gonna call on a second one. So that lag call to run, that point will turn on and it will tell you that, hey, it's looking for a lag to run. That's why it's running. And if you sit there and you're just looking at the system and you say, you know what, I want another chiller to run, it's because
override that,
you can turn that, you can override that point on and it will bring the other chiller on if you wanna override that.
Are we gonna get an alarm point that says it's run on, this one's on, 95% is over the demands?
You won't get an alarm for that. If
The high temperature, high chill water temperature alarm
I
maybe?
mean, you'll get temperature alarms, but it's not because it's over 95%. It's, you know,
Oh, just-
I mean, if it's something that you wanna do, we can look into, you know, putting some sort of
Well,
an
it's just like,
indication
it's
on
it's
it.
an automated system, we're not gonna be watching this all the time, so
Yeah,
it's a point.
he's wondering, when the second chiller stage is on, when it goes,
Mhm.
are we gonna get a lag alarm up on the FAS system here?
Well, you get an alarm if the other one came on because it failed. If the lag just calls to run, it comes on, you won't. I can make that
Okay.
point that,
No,
That might be a good idea, yeah.
Yeah.
that you can get like, you know, lag call to run. And
Yeah,
get
'cause
an
that way if
indication.
somebody either overrides it or
Yeah.
does it itself, at least we'll
It'll
know it's
alert
been
us that
initiated
there's a
one way or the
condition
other.
that
I can do
exists, because we're not
Okay.
watching
Cause
this.
now we can,
Or Jamie can do
Yeah,
that.
once that lag-
Anytime that turns on, Jamie can take care of
that way, if we know that we shouldn't have another machine on, well, obviously we got a capacity problem, they gotta come in and work on the chiller.
I think it's gonna be rare you end up in that
Very rare.
situation.
Yeah.
The only reason I say that because they're two 500-ton chillers, and during the worst case scenario that we had out there, we were only at about 75% of capacity of even one chiller.
Yeah, you, all that time, like.
It wasn't even- it was
you never
coasting.
turned another one on.
It was coasting when we had like 97 degrees out.
If
So-
you, I'm sorry, Steve, if you look at underneath the chiller too that's running, see
Mhm.
that load?
Yeah,
37%. So, you know, you start to see that, you know, stuck up over 95% for a period of time, you're close to starting another chiller.
Right.
So,
And that load override underneath that?
Well, right now, chiller one. This is this right here.
It says load
Says
override,
load
like that's supposed to be
oh,
lead
load
override.
override, I'm sorry. Is that lead or?
It says load, yeah.
Says
That's
load.
what Charlie wanted.
They both say load on both
Let me,
sides.
can you right click that real quick? Let me just see where it's coming from. Alright, I'll take a quick look, cause it might be, you might be able to override the load of the chiller to get a second chiller to come on, I might have had like redundancy type points in there, so.
Charlie might ask for it too when he was doing commissioning.
Oh,
Sometimes he
yeah.
wanted to be able to simulate things.
So right now it looks as though we right now it's chiller 1 is disabled. That's disabled, and chiller 2 is enabled. So this chiller's running. It's running at 37%. You're gonna get the information there. Refrigerant, it's at 76 degrees. Must be information off the chiller. Oil is at 104 degrees. Okay. We come through here. Chill water's coming through the chiller. We're watching the chill water. Excuse me, that's supply.
It's low.
So that's the supply coming out of the chiller.
I like that.
38 degree, the set point is 40. So that's supplying to the building chill water, which we're going to look at that screen next. We'll go backwards a little bit here and come from here. Chilled water return from the building. It's 62.2 degrees. It comes back through. You have 3 sets of pumps. Same as the condensing water pumps. The middle pump up there is a manual operation. The pump 4 and the pump 6 are automated. These are the ones that are automated, commanded, and all that kind of good stuff. Right now, pump number 4 is on. So water's coming up through, heading up. It's pressurized across to here, but that's closed. Closed evap valve, controlled by the chiller. So that evaporator valve's closed, and that's operated by the chiller. It's telling it to close. This one's open. Chill water's coming up through here. You see this values here? Very important. Each chiller requires minimum flow values. The minimum flow here, set point, is 450 GPM. This says 4 GPM.
Just, yeah, at the bottom of the scale, yeah.
It's something, but this valve's closed, but it should be looking at this one here, which this valve is commanded open, so you have 450 here, and you have 450, that's good. So you got 400 something flow to the chiller.
Are those flow switches there, or are they just?
Those are ultrasonic meters, aren't they? Meters?
The flow meter.
So there is-
Flow meters. They ultrasonically measuring the flow thing. It's
Yeah,
not a
actual-
paddle and
actual
That's
it's not a
tied
meter.
into the lockout,
You're talking about the DP switch of the chiller itself.
Yeah.
the
You're talking about a
GPM,
flow meter.
yeah,
Two different systems.
You want a proof of flow?
yes.
Proof of
Right.
flow is within the chiller.
Yeah.
Chiller
something
manufacturer.
can-
That chiller will
something
not
can
start if
happen.
it doesn't have proof of flow. That's why,
That's
We
that
had to
GP
maintain-
right there?
Yes.
yes, that's
They used
why.
to have paddles in there, the paddle
Yeah.
didn't
They
make,
didn't-
or
the
it failed.
DP.
There is a
not-
pattern, but
not
it's part of the train package.
Yeah, it's all run by train.
It's all by training.
Yeah.
This is important because the chiller bundle across there to get the right DPs and all that stuff, they want to maintain 450 GPM. So that, where's the bypass valve? Right here. This bypass valve, correct? This bypass valve is open and closing based on that flow rate. They need to get that pump to flow that much flow. Okay, if it's higher than that, you can bypass. If it's lower than that, you got to flow through that chiller. Okay, so that's what that is all about.
There's
Alright.
a little history on this chiller. With the minimum flow, like Steve said, you have a minimum flow that you're trying to maintain 450 GPM through the chiller. So if both chillers are running, it's gonna have, two sets of pumps running, two chillers are running, so it's gonna take the lowest flow based on either of those, so the valve's gonna control to try to maintain the lower of the flow. So if chiller 2 has
Right.
600 and chiller 1 has 300, it's gonna try to open that up to get, flow to maintain that one. So now the problem that we were having with this is that originally, well, I should say now what we do is when we start any chiller, we put the minimum flow valve to 80% open. So we're flowing all the water through the chiller, and then after that time period of 20 minutes, it releases the valve, and then it will come up under flow, and that ensures that there's proper flow to the chiller and that we have enough to make all of the flow switches and stuff across the bundles of the chiller to get flow. And we do the same thing with the chill water valve, chill water pump that's associated with that chiller.
Are you claiming that these are modulating valves? Not just two
No,
No,
position?
minimum flow
the
valve.
minimum flow, they left.
You're talking this one,
Yeah,
Yes.
yeah.
the bypass valve.
Yeah, the bypass.
Yeah, minimum flow valve,
Yep.
yeah.
On differential pressure, right?
There's only one of those.
Yes.
Yeah, it's not one of those.
So regardless if one chill, if the lead chiller comes on, the plant's enabled for the first time, that happens. If the main chill is running and you start a lag,
Mm-hmm.
that goes on. And also the pump associated with the chiller that's called to run goes to 80-something% for like 5 to 10 minutes
Mhm.
also, just to kind of push enough flow to make all the flow switches, and then it releases it.
There were some dynamics in the system
Yeah.
they needed to overcome.
Just to remember what it's called, this is minimum flow. You can send 500, 600 through these.
Right.
Yeah, it's just-
You can't go, it doesn't like to go lower than
Is that
those
one
kind of
big
readers.
chance of freezing?
Exact, you have a potential, yes,
Not
exactly.
as efficient either.
It's not efficient, icing out, it's not good. They want to keep the flow through the bundle.
That-
Okay?
One of the things that I see on the graphic on this,
Mhm.
I noticed on the condenser loop, it shows everything on the right side, on the evaporator loop, it shows on the left side. But the bundles, the way they're on the machines, they flow through the machine, they don't go out the same way. They go this way and then back out. Follow what I'm saying? If you
I
get two
understand
bundles-
it's not an as-built of the system, I get it.
It's just diagramming.
It's a diagraphical, hey, it goes in the chiller, out the chiller. Do you-
Unless they can put something in there showing the deviation with a line or something on the evaporator side and then the condenser side. Because in the past, when I worked on chiller diagrams, it was the other way around. When the water went through the bundle, you had the diagram where the condenser water went through, straight across that bundle. It's looking in that diagram, when you have two water lines, when you go back to the main chill water screen, that it's actually flowing, even though the pipe, the color's different, looks like it's going straight across and out
Okay.
on the flow diagram.
Does that impede, does everybody not, Does that impede with this thing, or is it's just more of a wish list type of thing that we should do?
What I'm saying is, you wanna separate a condenser water loop, and you wanna separate the chill water loops, showing it, you know? You don't on that diagram. When you go back to the main chill water system, see how it looks like the water's coming in on the left side and coming out? That's how a bundle is made on the chiller, okay? Not, let me just go back.
I totally understand what you're saying, Mark. I'm not disagreeing with you.
Typical flow on a chiller is it comes in here, it comes out here.
Yeah.
That's the condenser, okay? The evaporator does not go in and
I-
come out this
I think
way.
it's just for the
And
graphic.
same with this right here.
I understand what you're
Yeah,
saying. I
I think
understand what
it's
you're
just easier
saying.
for them
I
to
think
fit
it's
everything.
It's just
plotted
to-
on
how to
the
build it
screen
in
and trying
graphic.
to, you know.
Hard to swivel it around.
You know?
And do suppose to have the,
All right, so the third section of this, so you get the condensing, our chiller plant, and then the third one up here is this is the Maytemp. The Maytemp side, all right, and we'll talk about the switchover sections of that, where they cross over. So the Maytemp side here is Maytemp supply, Maytemp return. We all know the Maytemp chill water comes into the building in the steam tunnel head, rifles all the way up to the 12th floor. Okay, goes up to the 12th floor of the penthouse, and we come through here. This is up on the 12th floor. It comes through the side walls. It comes in. So I'm going to talk a little bit about these summer, winter valve business in a minute, how this thing actually is automated and switched over. This is how it all happens. When you switch over from Maytemps from our chillers to Maytemp chillers, it's this screen right here. Okay? This valve here is normally, it's not normally anyways, it's not closed, but in the winter mode, okay, this valve will be actually open. So right now we're running in the summer mode. If we look up here, and we have here P1, the winter mode is off. Winter mode enables off. Summer mode is on. Summer mode is on. So I just want to step through this for a minute. The valves are open. So if you look here, these valves here, summer valve, these are actually open. Okay? Allowing chill water to flow through from our chiller plant, okay, to the pump sets, circulate through our building, down to all the units, shield cooling units, AHU1, AHU2, H&Bs, everything that, fan cool units, all this business, allow it to come back up, return, and head back to our chillers. Okay? These are Maytemp, these are closed. These two valves stay closed. So Maytemp water from that's isolated right here. Our chiller plant's on. Okay? So if we go back to here, these are those valves right here that you see coming from the chiller plant. Okay? These valves are open. Okay? I don't know if I see the commanded open. Did I miss something?
Nope, they were a little higher.
yeah,
How did I miss it? Where is it here?
it wasn't
They're
obvious.
over on the left side, but they're up top.
Just
Winter
above the
mode
pumps.
status.
Up here?
Yep.
See
Yeah.
the summer valve's open, yeah.
Can I get at least a little thing down here, open,
Sure.
so I know they're open? Because these are closed.
Yeah,
Makes sense. These are open, so it's when you see the whole thing is that, and then especially when I click on here, I should see open, closed, and then this one here, closed.
Again, that's a manual switchover point. The winter mode enable is off.
Right.
And the summer mode enable is on.
That's right.
And then you also have that chiller enable for the outside air. So if your chiller is enabled and it goes below 50 outside, it's gonna shut the chiller off. So that number might, I'm sorry, so if it goes above 50, it's gonna enable. If it goes below 50, it's gonna shut the chiller off, so. Starting to get to these nights that it's getting cooler out. Might wanna either-
So, I'm just going to recap what Frank just said. So when we're right now we're in the summer mode. The chillers are on. So our chill water, like I said before, is coming through here, and Jamie's going to put down here. These are open. So we know these are open. So it comes out of that other graph. It comes through here, through the main one. All right. Comes down here. Goes to all of our equipment, pump, all that stuff, because these pumps are not used, remember. This is Maytemp, this is the Maytemp pumps. that probably won't run because we have temperature differential. But when we're on the summer valves, all right, or the summer mode, there's pumps over. Remember we talked about it?
Yeah.
It's oops, where are we? Back over here. Where are my building circulator pumps?
See,
Which one is
do
it?
they shoot 4, 5, and 6?
I didn't hear you say.
Oh, here they are. Sorry. Get confused. These pumps here are the pumps circulating the building thing, right? This is open. This is open. These are closed. You can show them they're closed now. So these pumps are circulating the chill water through here, down through here, down to our air handle, down to all of our equipment, back up the building, through here, through our pumps, and through the chiller. So that's how it's looping. All right? And then when we change it over, you should see everything change over automation-wise. You see all these statuses change and all this stuff. These open, these close, isolate our chiller. Everything shuts down over here automatically. May temp chill water then comes up through, right? Comes up here from May temp through the tunnel head through these pumps, but these pumps won't run because we have tons of differential pressure. Chill water then comes down the same line now because this is closed. This used to be the chiller, but it comes down these lines now, goes down through all the same circulation in the building, comes back up, and instead of going this way to the chiller plant, heads that way back to May temp.
Or through the check valve going, yeah.
Yeah, this is the deny valve he's talking about from the other thing. This modulates when it's in May temp mode.
On
By
chill
that
water
set
that's
point-
on right there?
By this set point, same valve, by this set point at 54 degrees, it's open and closing. It's letting the chill water come back, rat racing around our building, or exiting out to May temp. Okay? So that's really in a nutshell. I don't want to mess around with any set points and stuff like that, but we will when it's time to switch over our chiller plants and all that stuff.
So you're gonna put status on the summer valve and the
Yes.
winter valve?
Yeah, you got to put the opens and closes and all that stuff and make sure we know where they are, what the positions are when we're looking at them.
Cool.
Okay? Makes sense to everybody? All right. I mean, hey, not too many changes there, Jay. That's a good shot there you got there.
That was
Okay?
like the first system done, so I beat it up quite a bit.
Yeah, we all hit that one pretty hard.
Well, yeah, you had to because,
Sure,
yeah, the
they
whole
had a
damn
line
thing.
input too.
So, back to here, we know about the chiller plant. We went through all that stuff, exhaust fans. A2, 2, and 3, we talked about heat exchangers for hot water. We didn't open up. This is the heat exchanger system for the hot water system, for the building hot water. We got the 1/3, 2/3 steam coming in, low pressure steam, heat exchangers. We have traps coming out. And then we have our building hot water recirc through our pumping system. Serving floors, all building, all floors,
Yes.
all floors, coming down through, in here, down in, into the heat exchanger, coming out. We have temperatures throughout. We come up. Is this one whole system? 3 exchanges all on at the same time?
No,
As long as your hand valves are open, they would be, but
Yeah.
you can isolate them individually.
one of them is going to be on, you're gonna manually isolate, the other two are manually isolated.
Steam hand valves?
Yes.
Steam
Yeah.
hand valves. Okay.
So as far as the water side, the hand valves aren't closed.
These don't close.
If I asked Donnie
doesn't
the
make
fit of
sense.
that, and I don't know, they had all 3 of them open at the same time, and in the sequence it showed that only one of them was enabled and the other ones were manual. So if you guys swap your heat exchangers, however often you would swap through your heat exchangers, you would obviously valve off the ones that you don't want to use. But as far as right now, like, I don't know which heat exchanger is actually running. It looks like heat exchanger
Right here?
1 is running. So if heat exchanger 1 is on, 2 and 3, the steam side is isolated off. As far as the hot water side, I think it's still open.
Well, did you make sense? That doesn't make sense. You can't have water flowing through a heat exchanger. There's no steam going to it. You won't get anything. It'll just mix.
Yeah, it's just-
You'll never
it's
get
just
set
like
point.
That's what it's doing, it's just mixing with the,
Well,
just go through it.
I think that Charlie was just like, it didn't matter. I mean, the email that went out based on it, Charlie just kind of, said he was just going to have to shut the steam side off of it. So that's the way it was left. I don't know whether or not that's the way you want to operate it.
Yeah,
That's
No.
the way
it's
it-
just,
No.
it's just gonna circulate through. It's
Yeah, that's-
just wasting pump, you're just wasting pumping, yeah.
Well, it's not only that, but you're
Wasteful.
mixing your discharge.
Yeah.
You're mixing you know, how you
It's
can,
just pushing the hot water through. Some of them might get washed through heat, get some heat losses, but it's just, then you're wasting, you're pumping water through something you don't need to pump it through, so you're just wasting, pump power.
anyway, so let's go through it real quick so we understand. So we got proof of flow, which is this.
Proof of flow is on base, no, I think it's right there, see where it says
Pressure pumps.
DP?
Yeah.
Right here?
there, to
Oh,
the
this
left.
one.
That's the flow switch, that's your differential pressure on your right-hand side there.
Okay.
So it's a manual system enable, it's not based on outside air, I believe, right, let's see.
hot water year round, so you never reheat.
Yeah, so I mean,
Yes.
it's pretty much on all the time. You can disable it that way, you'll get flow, then the sequence will start, start to modulate the valves based on what you need. As far as the sequence goes, the pumps, as Jamie has for there, if it's sequence 1 that's activated, you can see the key below, pump 1's the lead, 2's the lag, 3's the standby.
Okay.
So, and you can see the current pump sequence, which is sequence 1.
One, we
So
can change it
pump 1
to-
should be
yeah.
the lead.
Yeah.
As you can see, pump 1 is actually
Yeah.
running, so if
Yeah.
pump 1 failed, pump 2 is gonna end up coming on.
I like that part. That's
Um,
nice.
So,
That all makes sense.
and then you can override the sequence if you want, so. as
Right, I
Jamie
can
also
change
has
this, hit
listed,
override, put it sequence 2, it goes
Override.
to that, and it changes the lead
Exactly.
lag and all the pumps.
So,
Yeah, it's really nice.
I wrote a story there.
No, but it works out. It works out nice. It explains everything, and it really, it's good. So, I see that. So I understand how the pumping works. It goes through. Then you got return temperature here. It exchanges. You got hot water supply out. Where's your set points down here?
yep,
Down
so
there.
you calculate it as 150 based on the outside air reset, and then you 146 up there. And as far as your alarm set points on this, if something looks a little strange on the bottom, it says hot water high 20, low 20, above set point, below set point. So where your schedule, your water temperature set
Right.
point is pretty dynamic.
Oh,
It
excuse me.
changes. It does that, so it's always an adjustable alarm set point, so you don't have,
I understand.
Alarming.
You got a hot
So-
water reset,
so
so
it's
it's a
gonna be-
scalable event.
it's always gonna scale with it.
You have a scaled event, so it's 0 to up to 180. I'm assuming.
140 to 190 is the range on it.
So you put a
150 to 190.
150 to 190.
150 now? Yeah, alright, so
Yeah.
change to 150.
outside air set point, 0 degrees out. It's gonna
190
be-
degrees,
190 degree water.
70 degrees, $1.50.
So
Oh, you're going that way. So 0 is going to be 190.
So technically 210 degrees, you're gonna go into a high alarm, and then 100, below 170, you're gonna get a low alarm.
Hold on a minute. Oh, I see. Yeah, but I see the middle. I'm trying to figure. So high, you're putting at the low. It's at 70 degrees outside. You're going to be at 150 degrees
Right.
Fahrenheit. And then you're sitting in the middle is what it's actually doing.
Yeah,
It's 69 degrees out, and we're at 150. So it's actually scalable and it's working right.
and at 130 degrees you go into alarm.
You go into a low alarm at
130. To calculate
You
the
go into
math,
high alarm.
the high above and belows will be based on that actual.
Right.
And then the hot water calculated set point, that's the hot water reset, you're trying to calculate it, that's where your calculation factor is.
Yep.
So that's where the, okay,
That's where the reset is.
I get
putting
you.
out based on-
That's what it's
You build
trying to
your
do.
own- You build your own reset schedule,
Yeah.
whatever settings you put in.
That makes sense, okay. And it goes through differential across the system. It's maintaining that differential, this here, the valve,
Yes.
right here. This is maintaining this valve.
That and this pump speeds actually are normally what'll get you the DP.
So you go to the DP, when you max out your minimum, that's when you crack that. So you're
That
down
would
to
never
your,
happen, but yeah,
right.
yeah.
And what ends up happening too is Charlie wanted to change a little bit of the sequence up. If the lead pump is running and it can't bring the pressure up in the system,
Mhm.
it will stage on a lag pump.
That makes sense.
Yeah.
You're trying to maintain your differential.
Right.
If you can't maintain it, that valve's completely closed.
Yep.
You're at 100% speed.
It turns on.
You
the
gotta
second
find
pump.
something else to help it out.
That'll probably never happen either, but
Right.
still.
I think it's like 95, and then it will shut. It's got to be like that for like 5-10 minutes or whatever.
Okay.
The range, then when it hits below like 70% on the drive, so as they start ramping down, the lag will drop off and the lead will continue.
Okay. Everybody else good with this? Alrighty. I think that covered everything on this. The filtrines. These, as the same as the other chiller plant, these are the filtrine units that are dedicated to small little split system DX systems. They're not little. That are dedicated to AHU3. AHU3 is serving the pharmacy area dedicated alone because it needs low temp deliverable air. I think the set point was around 46 degrees or something. Air off the air handler. We can look at that in a minute, but so to get that, you're not going to get that off May Temp or our chill water plant. You had to put in a low temperature chiller plant to be dedicated to get the proper chilled water temperatures across the coil, delivering supply air down to the 7th floor. So what they end up doing is putting these two chillers in. Okay, same thing as the other one. This is enabled on. This is enabled off. This here, and you can put something right on here. This is basically going to AHU3, Jamie. AHU3 cooling coil. That's where this is supplied from and returning from. That's it. That's all it goes to. So then it comes, it's returning out of the coil. Here's the return temperatures, pretty cold. Coming back, it's being pumped through the filtrane unit, out of the filtrane units, okay, and back to the coil. That's pretty much in a nutshell. And one pump's supposed to be running with one chiller. If something happens and there's a failures and all that stuff, we have a second chiller and a second pump to command on to keep our operation in our chilled water to that AHU3 serving that stuff to the pharmacy.
Those are ear cooled, correct?
These are air-cooled condensers on the roof, and it comes down here, the refrigeration circuits. These are just the large filtration units with a big sump bundle in here, keeping refrigeration, keeping this chilled water chilled down. Now, where am I?
Long points?
Oh, you put it up over here?
I didn't.
Chill
Yes.
outside and then it will.
Why wouldn't you click on that? Get along
It's
with it?
two.
Well, when you don't see the button, you don't know that there's something behind the graphic.
Okay.
So we try and
All right.
make it.
So, the associated stuff with this is AHU3 or lawn points on this. It'll talk about the filtrane unit. What's that mean? CHIR for?
That's an L.
Oh, that's an L.
Yeah.
Can we?
Lowercase, yeah.
Okay, that's chiller 3, chiller 4. We ran out of letters.
I don't know why. It wasn't me.
All right. Running status, cooling on. This is so you know chiller 4 that's on. Lead compressor set point.
There's something inside of the chiller itself.
Can you
It's a
redo
setting.
this here and put out so
Yep.
we know the same standards? And then alarms. This is just an alarming process. If anything goes wrong, at least we'll know alarming on it and stuff like that. So, not a heck of a lot we do with this screen. There's not a lot of interaction. It's a lot of just alarming and point structure stuff. Not a lot of controllability. We're not really doing any controllability out of this chiller, this lawn points. We're just monitoring stuff.
Couple
All right.
A unique thing to this is
you wanna
you
go back?
see the things on the top of the screen there, that enables.
Yeah, that's what I was wondering.
It's either, if the outside air is above that outside air enable, it's gonna enable the chiller, or if the dew point is above that 42, it will start it. So it's either or, it's gonna start the chillers. The middle piece is gonna come out. We ended up changing the lag chiller based, starting a lag chiller based on enthalpy.
Right.
So we're gonna have an enthalpy set point in there that's gonna end up changing. So the only other thing that's unique to this is we're modulating the
Well, Frank, we don't have chiller load.
you
Right.
don't have
We don't
trouble.
have- we don't-
No,
we don't
it's
have
not out. That's why it's
that-
coming
all right,
out.
That was left on there
That
for
was
the
left
the
on.
Yeah.
original intent, we didn't
So
scrap it yet.
that's coming out, and we'll just put the lag, lag call, with the dew point, set point, so you guys can, and
And
then I'll have Jamie put the dew point on the screen too.
just to let you understand what
I mean,
that
sorry,
means,
enthalpy. Sorry.
because when you have this is the time the thing when you have like if you have high humidity, you're trying to control humidity. You're not going to do it unless you get that chill water coil down and strip that moisture out, send it down to the 7th floor, and get the reheats to reheat up that air. This is when we have those beautiful design days where we get calls from the pharmacy saying it's 70 degree dew point down here. What's going on with you guys? Well, the only way we can control that dew point is by a low temp chiller delivering 40 something degrees off that chiller discharge, sending that cold air, stripping it down 100% saturation point right off the face of the coil, sending that air down. So the dew point now is at 40 something degrees, and then as soon as you send it down to there and you engage reheat within the pharmacy space, which it will do, because the amount of airflow down there. You're going to engage reheat, and if you looked at that what's it called, the isometric, psychometric chart, as soon as you raise that temperature up to a 68 degree level, and you get that saturation point and that dew point, it's going to drop right off. It's going to go back into that where you need to maintain, which we're trying to maintain. And aren't we doing control of humidity based on this?
Monitor the humidity in the pharmacy. It's one thing that was not on the 7th floor screen. There's a sensor in the pharmacy itself that we could actually put on there to show you the relative humidity of the room.
Yeah, we definitely have to have that. Alrighty, guys, I'm going to move up to the upper penthouse. We already saw cooling towers, right? I don't think we need to do these again. All right, up to the roof. We got the exhaust. I'm sorry. Did we do something?
So there's actually 3 levels of roof, Steve, so we have to.
This is the cooling tower area. This is the upper little area here with this elevated machine room cooling that's over here. And we have some exhaust fans on the roof that go, you click on these and it brings you the one that's, the screen there tells you which one it is and all that kind of good stuff. That'll be highlighted and it'll show you which one it is. Okay? We have H&V2. This is the
Mechanical one.
That's a mechanical.
penthouse level mechanical room unit. H&V only.
With cooling.
I believe this has cooling.
This
And it
one
does
has-
have cooling.
So it's H&V with cooling.
Yeah, it should be AHU.
So we'll just leave it as this, but we know it has cooling. This is maintaining our mechanical room itself. I'm not going to go through that. You guys are all well versed about how these things work.
At some point in time, Steve, we're gonna, we got that letter from, Eric that they're gonna put the ACs in those
That's right.
cabinets.
There'll be
To
a
maintain
cooling
that.
unit like Fegan 3. They didn't put cooling, but they have to have cooling in the vestibule area.
By the way,
That's
so
true.
far on the job, they've only talked about that in HV1. I asked about HV2. They're not talking about doing it on that unit.
Okay,
So-
well,
Well,
we're gonna need
that
some-
that particular unit there, I knew that we talked about that briefly about something, and that one there has those vent things. So when the unit's running thing, it's ventilating it's ventilating through. It's whether or not does that ever shut off. And if it shuts off, you know what happens. But in the summertime, I can't imagine that thing ever not shutting off.
No,
Well, it's
yeah.
just to maintain the UPS system so they
Yeah,
don't heat.
I can't imagine that thing ever shutting down. So if that happens, we'll address it.
Yeah.
That one definitely. This stairwell pressurization is always off, other than the fire command thing, and it's run by. It has components in there that have to stay cool. So we knew that. These here, like I said before, that's the elevated machine room unit. That's a train unit doing the elevated machine room. Why can't I ever get back, Jamie?
Is it-
Well, Steve,
Can
can
you
this,
click on that one again?
What's that?
Can you just click on that again?
Yeah, okay.
Alright.
Okay. These are the exhaust fans that are on the roof. I don't think I need to click on them. You know what they're going to do. The one thing.
What the
well,
station up there?
there's a thing, there's a distinction that needs to be made in these, okay?
Go ahead.
This is the middle roof. The one on the top part is the upper roof.
It's up.
Did you?
I
Did
I
you?
did that
oh,
on this.
He'll have it.
Okay,
Okay.
so we're gonna need to have a third
Just shade it
level of
different. You
cooling.
could shade
I
it.
mean, of,
Yeah, you can just shade it to
Even
it.
these little-
You can shade it, the upper one is a different,
Yeah.
upper.
because,
Upper
because,
library,
because this part is the middle roof. The cooling towers take from level 12 up to 14, and that's level 14 up there. And actually, where exhaust fan 22 is,
I think it's a
that's a
catwalk
level
right here.
14 because that's above the core stairwell.
Okay.
So that has to be shown that it's above, like the ones up there have to be
Okay.
shown.
So is this our outside air station? So this is where we
It's
get
just
at.
floating.
It's
It's
just
floating on the outside.
this is Benny one.
Hold generic on here.
So this is real important to remember, guys, because this is important. This is a lot of controllability. All the pointers, I'm assuming now, all this building's pointing to our stations for controllability. All of our outside air sensors. So if this thing goes astray, means all our set points and all our stuff, our equipment will be running astray. So this always will have to be, which we have it alarmed, and we have everything under control here. Ooh, you did that one already. Good job.
Well, no,
So-
that one, I meant to talk to you about that. I put that on the list and I checked it and it was fine.
Oh.
The other day, and now it's still reading fine again today.
Okay.
So I don't know what happened today.
I don't know.
I don't know what happened the day you were looking at. I put the thing
Jamie
back to
sets me
5
up
and
all the
10.
time. He gives me
Put
the
the
bad
spiders
crawling
graphics.
around
Put it
somewhere.
back.
He gives me the graphics, the bad
I
stuff.
do know when you're looking.
You said that unit's a train unit,
That's train.
That's an air handler.
That's a train unit,
It's not a DXS.
and it's under contract. It's DX. It's under contract with train.
They-
Train owns that one there.
Alright, cause the reason why I said it is, that's why I asked you to click back on it.
Go ahead.
It shows a water coil in there and a heating coil in there.
Okay. Jamie, for graphical standpoints, right down here, DX.
DX
It's a
system, if you
DX,
could.
a DX system.
That's
So it's not confusing? Okay,
because I've seen training air handlers too, that's why I was
Yep.
wondering.
that's a good catch.
Like the one that does the CV elevator roof, no, that's a DX also.
That's a DX.
That's a DX
And the
also.
one that does the Fagan elevator,
Okay,
mechanical room has the same thing.
one of the things we didn't do, well, hold on real quick. I know I'm running out of time. I'm really, you guys, please take your time afterwards. Chiller plant, we talked about low temp chillers. We saw those graphics. We saw the shield cooler graphics. The domestic
hot
water
water.
summary, we saw that. That's the one we saw on all the floors for chill waters and all that stuff. We didn't look at that one yet. We didn't look at air handlers, but guess what? You guys seen air handlers all the time. Same thing. Stairwell pressurization we'll take a look at. AHU summaries we'll look at. Construction exhaust.
There is a question on this.
Okay.
So there's an open proof and a closed proof.
Mine?
What's the difference? They're either open or off, aren't they? Or is there two? One
Yeah, but
hits
there's two
open,
end
one
switches on it.
Okay.
Yeah.
So
So-
the dilemma is that, you
If
know,
it fails in mid-range.
once you come off of open, like if the thing is open, it's hitting the open proof end switch.
Mhm.
Right when you come off open, it's no longer open, it's saying that it's closed. Well, according to what Jamie has up here. And then when it goes the other way, it's going to say that, the closed is now open. So it's kind of a little confusing.
Well, let me ask you this.
Until it's
If
actually made,
if I went to here and I hit override and I overrode that damper on,
which you
Go
can
ahead.
do.
right?
Yeah.
Yep.
And I'm gonna see that command go to
Is that for construction exhaust?
Open.
Yes.
Open.
Yeah,
Open.
maybe you should
What-
make
what's the
that
command?
on-off instead
Right
of
now,
closed
it's
open.
why is it closed?
Maybe
What
that'll
is
work.
what is my
On-off.
command? Am I
So if the
commanding? What am I
open
commanding?
proof
Well,
is
you'd be
on, then
commanding
you know
it
it's
to
open.
open on that floor. So you have construction on that floor. You want to open the construction exhaust. Boom.
Should we make it simple and just put this commanded on? So the first floor's on, so we know that's commanded on.
Okay. Well, you're commanding the damper to
Yeah.
open or close.
But aren't we also at the same time when we open this,
Problem with
it's
those
gonna start the
types
fan
of
on?
dampers, yeah.
Construction exhaust on?
Yeah. Well, those
100% open
are
until
down here,
it's
so
100%
it's
closed,
not
yeah.
actually going to do anything unless those are.
All right.
two
So there's two things you have to
positions.
do. You have to command the damper open. So you command it to open. That'll say That'll
Yeah,
say
see the
commanded
proof
open.
command to go-
Then you're
yeah,
gonna look over here, and this will finally say proof open.
When it's fully made.
Well, but
Yeah.
when it's all said and done,
Mhm.
open, and then it'll say close.
Open.
We open. So you see say open, open, open.
Correct.
If it works right,
Correct.
then you come down here and you command the fan on,
Fan on,
and everything should be fine.
yeah.
If you go the opposite, close, close, close. If you see that it's open, open is still closed, that's just kind of tell you that it didn't make all the way to the proof.
Yeah,
Right.
exactly.
Doesn't
You gotta
mean
wait
that
a
it ain't
little
working.
longer.
It might not be working, but there's something wrong with the
It's
proof.
partially open, yeah.
I think everybody can figure that out. So that's construction exhaust. Make those changes that we said, the small ones for construction exhaust for the head
Can you
items.
click on the domestic?
Oh, you.
This one
On
here,
you.
Yeah.
that's the one with the plumbing shop, all the readings. We talked about it for floors.
Mhm.
Okay.
Yeah, we did not have this.
No, I am, but
Are you good, Mark, or you want to look at it? Remember, this is not over. You can always look at this. It's always out there. If you want to look
Yeah,
at
it's
this,
just
mark
the
it up
first-
and
it's
give me
the
the
first
things.
one.
I see the floors,
This is the
but
third go.
where's the heat exchangers?
There's no heat exchangers, domestic water feed. This comes from the building. It's like coming from the city.
You've
the
got
cold
domestic
water.
heater down
It's
in
the cold water and the hot water.
That's what you're thinking.
That's what I'm saying.
Oh,
Yeah.
yeah, yep, there is one down there, it's in the mechanical room, yep.
Do we have any conductivity to it?
We have a discharge sensor, a supply temperature sensor in the pipe, that's it.
The
That's
sub
it.
basement low zone. Is that what that is?
Temperature.
Yeah, you have
Yeah.
a sub-basement low zone, you have a fourth floor high zone.
So that'll
That's-
tell you right there.
Those are the.
That's all coming, that's coming out of Maine.
No. It's all hot water heated from the building. It's got its own hot water heaters. There's a hot stairwell pressurization real quick. This is the stairwell pressurization for fire alarm activation in the stairwell. And so if we have a smoke alarm that goes off, this fires up and pressurizes positive pressurization into the vestibules that go into the stairwells. It pumps air into all those and pressurizes them all. Okay? That's that system there. All right? We don't have we don't have a riser of the stairwell in the fire thing like we do in the main building. In the main building we have, or the CB, we have a little riser diagram with the feeds in. It comes down, and it feeds in each one. It tells you here's HV1. It comes down. It feeds in. Okay, doesn't know what it tells, but it just tells you an idea of how that thing is getting down and where it's feeding. You know what I mean? A quick little diagram on it.
So that FCC on command status, that's the status from the actual fire control center?
That's right.
Yes.
So they can override right from down there.
Yeah, they have control of this.
And then you can turn it on from above.
Okay. So anything we're missing here is just an enhancement of that, how this is fed down there to the floors for the stairwell, the liner, the one liner, so everybody understands that when they command this on it, where it does. All right. HV2, mechanical room ventilation. Okay, it's the penthouse level. You guys know about this. All right. AHU summary screen. It's just like the rest of our summary screens. It's going to populate all of our AHUs, H and Vs on one screen. You can go by and I see a lot of X's.
Yep.
Those are for us to fill in to say where they
Correct.
want to be. What's the
When-
normal values?
When it's handed over, you know, this is our perfect situation.
Right. Okay.